These formulas today, I don't think it's anything too crazy. And just to really help the cause, I kind of tried to help the cause and set some things up here for you. So first off, complete the table. So this is what I say, it's a little different looking than what we're used to. You have to fill in this table, of course, and compounded continuous for our interest. So here's your provided formula, of course. I'll always give you the formula. So I'm taking a look at the pieces of the puzzle here that we have. Initial investment. So you do need to know in the formulas what the letters stand for. P, remember, is your initial investment. So you can see that's why I put the $2,000 in there, just to save you a little bit of time. Rate, as always, I do not have a percent key on the old calculator, so I put that as a decimal. That's why you have the 0.02, of course, in there for R. So we are trying to find here the time for it to double. So of course, time, we're solving for T. Now here's what's maybe a little different. Very fancy, kids, very. So $2,000, if I want it to double, it's gonna turn into $4,000. There's the magic, okay? In the past, they would have just told you the 4,000 specifically. Now, you have to maybe double that amount, or we really might get crazy and triple an amount. So I came up with the 4,000 because it said double. Now this is easy to solve. This is a good review of the previous section solving equations. As always, isolate the expression with the variable. So I want to get this e to the 0.02t alone. So I'm just going to divide off the 2,000. You can do that in your head, right? Got it. Now we're in exponential form. I want to know what t is. I want to get it out of the exponent, so I'm going to convert to log form. And I think we're past the point where I have to keep writing log base e. I'm pretty sure we are, because you know by now what's log base e? ln. So we're going to have the ln, 2 moves to the left, 0.02t to the right. Now from here, I would be on my calculator. I wouldn't write anything more. Grab your calculators, you punch it in. What's the ln of 2? And then divide by 0.02. And it doesn't tell you what to round to, so surprise me. Got it. And it doesn't say what to round to, so round to whatever you want. Whatever you want. If you want 0.66, put 0.66. Okay. Now, next thing we have to find, the amount after 10 years. Well, the amount is the A part, of course. Now, I'm still using the exact same formula over here. I'm just going to jot it down so it's in front of us again. So we want to find the amount after 10 years. Well, our principal is still the $2,000. Our rate is still the 2% that they provided us in the table. And now you know the time. We're looking at a 10-year time span. And we want to find that final amount. Now I like this one because I really don't have to do any more work because you already have A isolated. Just punch that in the old calculator. And remember, we're finding the final amount in your account. So I'm going to put a dollar symbol on. And how many decimal places should we round this one to? Yeah, I would go 2. So 24,442. What is it? I got too many 4s in there. 2, 4. I can't write and talk. 2, 4. All right, and what do we have for the change? 80 cents. Okay. So again, we've used all of these formulas. You've calculated all this stuff. It just looks a little different. It's just now in this very fancy table formula. Again, you'll always get the formulas. All right, complete the table for the savings account, compounded interest, a continuous again. Still the same formula, still the same stuff. Okay. So initial investment, of course, that's our P still. So you can see I put the 1,000 in for us already. Now, first blank in our table is the rate. So we're going to solve for the rate, of course. Time to double. So of course, 12 years, there's my time. So I put that in for it, of course. Now, I came up with the 2,000 again, super, super fancy, because it says double. So I took my $1,000 and I doubled it. That's how I got the 2,000. Now, we're going to solve this, of course. We're going to isolate our term with the variable. We're going to divide by 1,000, which you can just do that in your head. So, of course, we're at 2 again. As always, I think we're past me writing log base e when we convert it out of exponential form. We know that's ln. 2 moves to the left, 12r to the right. So let me give you a second to type that one in. And what do we got for r? 0.0, what do you round it to? And then of course, just when I list the answer up there in the table, it wants it percentage style, so I'm gonna put it 6%. Now, I rounded to, I made it 5.8%. Is that wrong? No, it doesn't say what you round to, surprising. But if I round something maybe a little differently than you do, it is gonna throw off our final answer, so don't freak out if yours is a little different than mine. Okay, amount after 10 years. So remember, the final amount, that's what we're solving for A. So again, I'm just jotting it down so it's right in front of us here. So as always, our initial amount is still the same. We still have the $1,000. We just figured out the rate was 6%. So I'm just gonna put that in as a little decimal. Okay, after 10 years, so there's your time, we're gonna figure out the amount. So nice and easy, A is a loan, just punch that in the calculator. We're talking amount, so I'm gonna put a $sign on it. What do you got? 1,000. What do we have? Because mine's a little different because I rounded the rate different. So what do you guys have for it? 1,000. What's our change? 1 cent. Okay, any questions on that? I'm trusting we typed that in right, because like I said, I rounded the rate different, so I have a little different answer. All right. So again, nothing new, just in this table style. So flip it, we're gonna do some more. So of course here we're just solving for different things on the next page. So you're like, why are we doing what? Well, front page I gave you the initial investment. Here we're gonna solve for the initial investment. We're gonna figure that out. Complete the table, compound continuous, same formula. Okay, we got initial investment, of course, P. So you can see that's what we're solving for. Now the rate, of course, percent, I put that as a decimal. Got it. Now, I'm working off of this. I'm gonna do this time to double in a minute, because they also give you this information. They tell you the amount after 10 years is 2,500. So I plugged all of those numbers into the formula. I don't know P, I know the rate, I know I'm at 10 years, and it should be $2,500. So you can take this expression, this E to the 0.035 times T, and you can type that in your calculator. That's just gonna be some gross decimal. So you can see I look at my cheat sheet because I typed it in earlier, and I clearly don't remember all of these decimals. And again, depends what you round to. Now, that's not very difficult to solve for P. How are you solving that for P? Divide, just divide. I can't say I'd write anything else. I just divide that out in my calculator and put the answer in the box. See what you get. 1,000. Got it. $1,761. What do you got for change? 80. And again, if you rounded this to like 0.42 or something, you might just have a little bit different change. Fine, I don't care, whatever. Okay. Last thing we have to find here is this time to double. So, you know, I like to just write the formula so it's in front of us. Now, couple different ways you can do this one, okay? First off, we know the rate. I'm going to go ahead and put that back in, the 0.035. That doesn't change. We're trying to find the time, and we need it to double. So at first glance, I was like, oh, this is going to kind of be some bad decimals. I don't love it. I could put the 1761.80 in here for P, and then hit times 2 for the A. I'm going to have some very large, gross disgusto decimals that nobody wants to deal with. So we're going to work smarter, of course, not harder. If we're going to double, that means every $1 turns into how many? 2. So I could put whatever numbers I wanted in, 100, 200, 500, 1,000. I could do this all day. Nobody wants to do this all day, but you're always in the ratio of 1 to 2. So I could put the 1761.8 in here and double it, but when you divide it off, you're in the ratio of 1 to 2. So let's just start with that and make it easy on ourselves. Now, of course, let's get the exponent out of the E, so I'm going to convert from exponential to log form. I'm not writing log base C anymore. We're past that L into 2. 0.035 T to the right. Okay, let me give you a second to punch that in. I don't know, round to whatever. How many years? Is that what everybody has? 10.02? I got something bigger. 19.9. 19.8, or if you want to round it to 20, whatever you want to do. Should have something 19.8. I'm going to label. Any questions on that? Maybe just a decimal point. Okay, last money problem, because I don't know about you, I'm kind of getting sick of the money problems. We're going to do some science ones, some half-life. All right, complete the table for the time necessary for P dollars to, okay, we're getting really fancy here, triple, when the interest compounded continuously at these different rates. Now, notice the table's not as big, there's not as much information, but there really kind of is. So, triple. They didn't give us an initial investment, so I just have to be smart enough to know if we're tripling money, $1 turns into $3. So I put the 1 and the 3 in there. I know I could make it any numbers I wanted. 500 would turn into 1,500. 20 bucks turns into 60. You're just always in that ratio. $1 is going to make $3. Now, 3% is my first rate. So I'm going to put, we don't necessarily need to keep writing the 1, but I'm going to put it for dramatic emphasis. I'm going to put the 0.03 for our first blank we have to fill in. Now, same spiel. We're in exponential. I'm going to convert it to log. We're past writing log base e. We all know it's ln. So we have ln of 3. So, of course, in your calculator, you're typing in ln of 3, get that answer, and divide by 0.03. Nice and easy. What do you got? Like it. And I'm just going to label, since it's time, I'm going to put years on it. Now, really, the next one is just as simple, except we change the rate to 5%. So I'm going to have my $1, my 5%, and of course, since it says triple, my $1 turns into $3. Of course, if it said quadruple, dollar turns into $4. You get the gist. Okay, let's convert it, log base e or ln. And let's divide this guy out. Final answer for this one. Perfect. And again, if you round it to 22 or something, I don't care. It doesn't specify what to round to on me, so I'm not picky at all about it. So any questions, how to type those in, anything like that? All right, we're sick of the money problems. Let's do some science problems. A couple science. Okay, so half-life. So we've talked about half-life. We've seen half-life in here before. Of course, you're going to be given the formula. Always be provided the formula. T, of course, is time. It's got all the variables over here. Now, if you're ever, here's a pro tip for you. If you're on your test, you're like, oh man, I can't remember A0 and A F, like whatever else. 0, of course, what you're starting with. F is the final. Just like, it's kind of the same pattern as these. You started with $1, you ended up with $3. It's always the first variable is what you start with. Now, in the table, let's be honest, I really don't care about the isotope name, whatever, okay? The half-life years is 5730, so they plugged that in. Your initial quantity is the 3, and we're finding them out after 1,000 years. So the T, of course, is your 1,000. So I just set up everything for you. Initial amount, 1,000, 5730 for the half-life. Punch it in. Round to what it is. Do you guys cover this in science at all?
Not at all. I remember what isotope, half-life, I divide by 2.
Half-life, that's where the half comes from in the formula. Well, science action for us all.
No.
Would this be like biology or chemistry?
Biology, for sure.
Biology, okay. Yeah. Clearly my science knowledge is rusty. All right, what do you got for your final amount? 2.66. And I'm just going to label grams. Okay. So again, you'll be given the formulas, easy peasy. All right, let's do one more science half-life one. Okay.
I did that too, and I got 0.8.
I typed this in. I'll have to look at your calculator. All right, here we go. Same spiel, same formula up here. It's nothing exciting, okay? Now, here, of course, our half-life, the 24,100, your amount after 1,000, so I put that in, of course. Here's what is different. They gave you the final amount. You're finding the initial amount. So, not that that's a big deal, but we just have to do a little bit more work here. So, first up, you can type this entire expression into your calculator. I mean, it's kind of obnoxious, and of course it's gonna be a gross decimal, but we can type that in. So you can type that in, so 1/2, and I'm gonna raise it. I'm gonna pull up the calculator. So 1/2. I mean, you can use your horizontal fraction bar, of course, if you want. I already forgot the exponent. 1,000 divided by 24,100. So raised to the 1,000 divided by 24. You know, I hate typing on this thing, so I'm just gonna double check I don't have a typo. All right, and I'm just gonna round that. Let's go 0.972. Let's go 0.972 on it. Okay, how are you solving now for the initial amount? Easy. Divide it. Okay, divide it. You divide it. You divide it. 0.41 you should get. Okay. Any questions on how to punch that guy yet? And I'm not picky about the rounding whatsoever. All right, final problem of the day, and this is of course a calculator deal. Obviously, it looks wordy, but it's very simple. When $1 is invested in an account over a 10-year period, blah, 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 the amount, focus, my friends, final two, is given by those two different formulas. Depending on how they set it up to pay the interest, the simple interest at 6% or the compound interest at 5.5%. Use your graphing calculator to graph both of them in the same viewing window, which grows at a greater rate. Okay, so we have to type both of these in. So of course in your y equals menu, I just of course change this to x, not t, clearly. And then same for the second one, instead of a equals y equals. And of course, instead of the t, I just use the variable x in our graphing calculator. So those are a little obnoxious, I know, to type in, but it's nothing crazy. Type them in. Let me give you a minute to type them in. We'll take a look at the graphs. And I'll try not to complain about Texas Instruments, but no promises. Can you? Can you? Can you? Can you not? Can you? So you can see I've got them typed in. You've got them typed in. We're typing them in, right? We're typing them in. Typing, Emma, we're typing, right? We're typing.
We're typing.
We're typing. Emma's typing.
I'm typing.
Emma's typing fast.
Yes. I don't want to type it. I'll just wait. If someone else-
What kind of attitude is that?
Because it's
Where is our grit?
It's Monday. I'm tired.
Oh my gosh, it's Monday and I'm tired. Okay, so you typed them in, you hit graph.
Yeah, I can.
Okay, now what do you, I am going to complain about Texas Instruments. When I look at the graph, what's your gut instinct about these?
They look the same.
But, I'm going to go to the table. Because it asks you which one grows at a greater rate. So I'm looking at the table, of course. I'm ignoring the negatives because we're talking about t being a time value. So I'm looking at 0 and up. And I'm like, wait a minute. They are starting to differ. Not by a lot, but they are starting to differ in the y columns. So the real question that it wants you to answer is which one is growing at a greater rate? Which one grows faster? The second one. Clearly you can see this guy's getting bigger faster. So my final answer is that, I'm just going to make it easy, let's just circle the second equation. That one grows faster. So again, don't always touch the graph on Texas Instruments. You sometimes need to analyze the table. I think we've been through that before, right?